We're not having a delay on this
X
slide.
and a Y.
But it's just like over 3.
Huh?
All right, guys. Go ahead and open your notes package for me. We finished. No, we did not finish. We will not finish all of this today. Okay, there's a lot in this unit.
Is this a hard unit?
Yes and no. Like we're adding to what you already know. So we're still doing confidence intervals and hypothesis testing, but now we're doing with instead of like one sample, we're doing 2 samples. We're finding like differences in proportion.
There's still a lot of writing. Oh, a lot more.
I have like essays on my period.
Yeah, like your conclusion is very similar. It's still if you're doing a hypothesis test, it's still, since our p-value is blank, which is, greater than or less than, we reject, it's all of that stuff still.
Yay.
Last unit was hard. Your first time with the hypothesis. But later in the year, you'll think that's easy. You know what I mean? So it's kind of like in calculus when you do those first. When I do and something, but then you do zero. Use a trick with, how you do within each topic. All right, guys. So let's look at what we are doing with Unit 6. Maybe. If my pen will work. We did everything with a 1 sample before, so now we're going to do it with 2. I've haven't seen it.
I used to have a lot of fun when we were done.
It's good times. Okay, now I can write. So off to the side here, I'm going to write what you already know, what you already should know, if we're talking about 1 sample. So I'm going to make a little column over here. Okay? So instead of comparing 2 proportions, if we only have 1 proportion, this is what you've already done. So what you knew before when we were with proportions was the mu of p hat, that just equaled whatever p was, right? Okay, we know this. Now we are doing mu of p hat 1 minus p hat 2. So you just have 2 proportions that you're looking at, and you're looking at the difference. So that's going to equal, the equal sign kind of got lost there, p1 minus p2. Okay, it's very similar, right? It's just, you have 2 of them now. What about our standard deviation when we had p hat? What did that equal, guys? Remember? P times 1 minus p over n, right? Okay. Now that we have 2 of them, it's the sigma p hat 1 minus p hat 2, and it's the same formula, just twice, okay? You have both of them to consider. We'll get into why it's adding, even though we're subtracting, but right now, trust the formula for me, okay? So you're just doing whatever your first proportion is, whatever the second proportion is. You do keep them under a single square root, though, okay? All right. And again, we'll look at more of that in a little bit. Your conditions before, you would show n times p was greater than or equal to 10, right? And n times 1 minus p greater than or equal to 10. Okay, what you have to do now is basically do it twice, once for the first proportion, once for the second proportion, but now we're saying greater than or equal to 5. Okay, you have a smaller number that you have to make it greater than or equal to. Random sample is the same. Ignore the 10% rule. That is not, it's never on the rubric, so we're not going to worry about it. The independent part is new, okay? So when you're looking at that with independence, it's just that a person cannot be in both populations. Okay? So like the first one we're going to deal with is the proportion of girls who dress up for Spirit Day and the proportion of boys who dress up for Spirit Day. You're not going to be in both. Okay? Does that make sense? And you just have to state it with your conditions. Like we'll go through checking it on the first example, but you just state these examples are independent from one another. All right. We have to name what we're doing. Okay, that's not new. Before we just called it a confidence interval. Or a 1 proportion Z interval. You guys read that okay? And we had P hat plus or minus our critical Z value times our P hat times 1 minus P hat all over N. Right? This is all familiar to you, the stuff I'm writing over on the left. Good little review of all of that for you. So now what we're doing is we have a 2 proportion confidence interval. Instead of a 1 proportion Z interval, it's a 2 proportion Z interval, okay? It's the same idea, you just now have 2 samples that you're looking at. So instead of just P hat out here, we have the difference in our 2 P hats that we know. You've got your critical Z, that has not changed. The formula, it's this, but twice, okay? But added, yes. And then if we're doing a hypothesis test, what we did before was a 1 proportion Z test. Okay, and now we would be doing a 2 proportion Z test. Make sense? Okay, we just have 2 proportions that we're looking at. We would find our Z before. Okay, we're still going to find a Z, but you have 2 P's that you're looking at here. So instead of just P hat, it's the difference in your P hats. And instead of just P, it's the difference in your P's. Okay. Questions so far? Okay, we're going to jump around in your packet a little because I don't want to go through all of the mean stuff too before doing an example. So let's go to our first proportions example. So we're going to skip. Okay. This first sampling distribution problem here. All right, so we are told the proportion of boys at Madison who dress up for Spirit Days is 0.65, while the proportion of girls is 0.75. So we've got a random sample here of 55 boys and 45 girls from Madison. What's the probability that the proportion of girls who dress for Spirit Day is less than 0.08 more than the boys? Okay, the last sentence of that is weird, right? Like it's confusing the way it's written. Okay, so let's go through our steps and figure out how that relates to what we're actually doing in this problem. Okay, first we need to define a few things. What is, I'm going to give 2 things here. All right. The P for girls and P for boys. What do you think that's representing? Proportion of girls at. Okay, so this is the proportion of JMHS girls. Who dress up for Spirit Days. Okay, so that's our first parameter. But this is a two proportion problem. So what do you think E sub B is? This will be the only thing different. Yes, boys. So proportion of JMHS boys. Dress up for Spirit Days. Okay. All right, and let's write down what we know. Do they tell us from the population what the proportion of girls is who dress up? Yes. What do they tell us? For girls, I think it's 0.75, right? Okay. All right. Do we actually know our P hat, like sample? We know the sample size, right? It was 45. But do we know the proportion out of those 45 who actually dressed up? No. So we're just going to say that's a question mark. We don't know that piece yet. Then for the boys, the actual population parameter here, that is the 0.65, right? Again, P hat for boys, we don't know. Sample size, we do know. It is 55. And I need my subscript on both of those. I left it off. So this is girls, this is boys. So make sure, even with your ends, you're telling me which one goes with which. Okay, so there's just a lot of labeling that's making sure you know which is a part of which proportion. So far, not bad, right? It's just like doing two proportion problems in one. Okay, you have two populations you're defining. All right, now we're going to actually do our conditions. And you have to do it twice. So we do it once over here for the girls, and once for the boys. Okay. So the first time is going to be N sub G times P sub G. So that would be 45 times 0.75, which comes out to like 33.75, I think. I'll save you the time. Is that greater than or equal to 5? Yes. Okay. All right. Then I have to do N sub G times 1 minus P sub G. So that's going to be 45 times 0.25. I think it's like 11.25, which again, greater than or equal to 5. So, normality, are we good? Yes. Check. Was it a random sample?
Yes.
Yes, stated, right? SRS stated. All right. And then independence. Yes. Okay. You don't have to write this every time, but just for the first one here, can't be in both groups. Okay, that's what that means. So when you're going through problems, the rest of them, and your homework set and data journals, all of that, you just need to state it. Independent check, yes. They know then people grading it with your rubric will be like, yep, they looked for independence, we're good. Okay, so it's not like there's a bunch of work you have to do for that. You just have to show that, yes, I've thought about the fact that they're independent. Okay, so over on the other side, it's going to look very similar, slightly different numbers. So n sub b times p sub b is going to be, what, 55 times 0.65, 35.75, definitely greater than or equal to 5. N sub b times 1 minus p sub b, so that's 55 times 0.35, 19.25. So we're good there. Still a random sample, right? And independent. All right, we're okay with that. Okay, now we actually get to do the problem. Okay, we're talking about the proportion of girls dressing up for Spirit Day compared to boys. Like looking at our two population proportion, girls dress up more often than boys, right? Okay. We want to know what's the likelihood that our sample, that they only dressed up 8% more than the boys, okay? So that's what we're going to look at here. So when we're doing our sigma, finding our standard deviation, it's going to be p hat of the girls minus p hat of the boys. You're just looking at the difference, so technically you could have switched boy minus girl. I usually like to keep it positive, so I knew the girls was a larger number than the boys, so that's why I did that first, okay? And then we're just going to go through what this formula would look like. It would be square root p sub g times 1 minus p sub g all over n sub g, okay, plus the boys' proportion, so p sub b, 1 minus p sub b, all over n sub b. Are we okay with that formula? All right, so the values that we have, proportion of girls was 0.75, 1 minus 0.75 is 0.25, and the sample size for the girls was 45. Then for the boys, that proportion was 0.65, 1 minus that would be 0.35, sample size was 55. Okay, try keying it in. Let's see what you get. Did you get 0.091? And guys, actually, like, make sure you can key this in correctly, okay? Sometimes you and your calculator don't get along very well, so make sure everything's okay with it. You gonna make it there, Trey? You're like sliding. All right, so that's our sigma, okay? Let's think about what we're actually talking about. We're talking about the difference in the proportion of girls who dress up versus the proportion of boys who dress up, right? This was that first thing on your formulas on the other side. So P sub G minus P sub B is where I'm getting this information from. So what was the proportion of girls? 0.75, and the proportion of boys? 0.65. So the difference between them, looking at the parameters, we get 0.10, right? Okay. We're going to make a picture of this. That 0.1, that's the difference in the proportions from the parameters here. It goes right in the middle. That's our mu that we're talking about. Mu, the difference of the proportions. Okay? Oh, yeah. Yep. I'll always draw a picture. All right. The problem said, what is the probability that this difference is less than 0.08? Okay, where do you think that 0.08 goes on my picture? Yes, over there, right, on the left side. So 0.08 is somewhere over here. Yes. It's actually in the problem.
Oh, okay.
Do you see it way up here? It's that weird last sentence that looks really confusing when you first read it, which is why we're going to do it in little pieces. So the probability that the proportion of girls who dress up for Spirit Days is less than 0.08 more than the boys. That means that the difference is less than 0.08. Okay? So the 0.08, that's what I'm putting on my picture. And less than 0.08, so I'm shading over here. Okay with that? How am I going to find the area of that shaded part? Norm CDF, yes, okay. I'm going negative infinity to 0.08. And then 0.1, 0.091. So this is mu of p hat girls minus p hat boys, and this is sigma of p hat girls minus p hat boys. Okay. Let's see what she gets. What are we getting? 0.413? Everybody okay with that? Okay. All right. All we have left is writing our conclusion, guys. We're almost done. So when you ask, is there a lot of writing in this unit? Yes, there's a lot of writing in this unit. You'll be okay. All right, so what this means. Again, the question said, what is the probability? So we're looking for a probability. So what we're going to say is there is a 41.3% likelihood that a simple random sample, so SRS, of 45 girls and 55 boys at JMHS will result in the proportion of girls dressing up for Spirit Days than, oops, not than, 8% more than the boys. It's not a simple conclusion, is it? Take a second. Try to digest all of those words. So let's look at the pieces of it. So the 41.3%, that's easy, right? That's what we did all the actual math for, was to find that. And then we're talking specifically about samples that were exactly the same size as the sample we took. So 45 girls, 55 boys, specifically from JMHS. Okay? The rest of it comes from the question. We're talking about the proportion of girls dressing up more than the proportion of boys who dress up. And we want it to be, 8% or less more than the boys. So the girls are still dressing up more than the boys, but only up to 8% more than the boys. Okay? Questions? Okay. Silence is just, we're okay, or we don't know what to ask. Should we try another one and see? Okay, it comes up. I like that. All right, go ahead and turn the page. Let's see. Let's do another proportion. Okay, so this time we are doing a 2 proportion Z interval. So we're going to find a confidence interval now. Okay, we've switched over to Langley. We have new samples. I want you to try to do the first part. So what we did here, on the one we just did through the conditions, I want you to try to do that with this Langley problem. And it's not all going to be exactly the same, but I want you to see if you can figure out how to do just through the conditions, okay? I had to squeeze in the conditions above. I didn't feel like everything fit in the space, so you may want to use the space above the problem too. So you can talk to each other, conditions, defining what P of G and P of B are, and then what do we know, what do we not know. If you're feeling good and want to actually start on the confidence interval, feel free to add all the formulas. If you're not feeling good, just I want to give you time to write all the stuff. First part. What? Yeah, it doesn't say random, so what would we say? It's assumed. Yeah, I know they didn't actually say that this time. So you have to define this. Think about which of these three things you have to do. I want to give you time to actually write it. Think about it, write it, and remember it. Just what? This little fellow looks tired. It's a great jacket. It's just the floor. So you guys really I'm not supposed to touch you right after break. So that's yeah, what we got on this one there, take this every day. So it's different order this year. They're not able to get values for practice. No, I don't think. Yeah. Your Yes. Just like normal. It's very similar, but you have to use pens. I'm going to start writing the conditions and stuff up here so you guys can check. right, guys, so your conditions, you're doing your n sub g, p hat sub g, n sub g 1 minus, p hat sub g, all of that. Random sample assumed, independent, yes. Again, you can't be in both of these groups. Same thing for the boys. I know it's tedious, guys, but you got to go through checking your conditions. This is like the free points on your AP exam, okay? A lot of times when I'm going through the rubric on your test for the free response questions, 1 out of the 4 points is did they name the test or confidence interval, and did you check conditions? So even if you aren't sure where to go from there, could you check conditions? Yeah, so sneak out every little free point you can on that AP test, okay? Or from your tests in here too. I know. You need lots of room for these, I know. All right, guys, then defining P sub G. This is the proportion of Langley girls who dress up for Spirit Day. Do we know what P sub G equals this time? No, but do we know P hat? Yes, that's our like 127 out of 210, which is 0.605. And obviously then N sub G is 210. Okay with that? Okay? Then again, I know it seems redundant, but yes, write out all of this. So proportion of Langley boys. Dress up. For Spirit Days. All right, so P sub B, again, we don't know that one. P hat sub B, we do know. That is what, 118 out of 200? Which is 0.59. Okay. Are we okay to that point? Yes. Let's do the actual confidence interval. So we are going to construct a 95% interval. We need to know what we're looking at. We're looking at the difference in proportions, girls and boys who dress up. So I'm looking at 0.605 minus 0.59. Does that make sense? It's just the difference in the proportions. You can find out what that is. You can write it like that in your formula. That's okay. All right, and then I also need to think about sigma of the difference in proportion of girls, boys. So that's going to be big square root, and then 0.605, 1 minus 0.605, all over 210, plus 0.59, minus 0.59, all over 200. I think that comes out to be approximately 0.048. Okay. Definitely running out of room here. So my confidence interval, that's this difference, this 0.605 minus 0.59. And again, if you found what that value is, that's completely fine, okay? Plus or minus, what's my Z-crit for 95% confidence? 1.96. You could write the formula for this, or I already figured this out to be about 0.048. try keying it in, make sure you get the right interval. Because on the confidence interval test, there were a few of you who had everything written correctly, but then would write the wrong answer for the interval. So I want to make sure we're okay with writing the interval. Are you getting negative 0.079 and 0.10? Okay. Now we have to write our conclusion. You don't have to do a confidence interval. Like, it's okay to draw a picture for that. Every hypothesis test, definitely draw a picture. Okay. All right, so for this, we are 95% confident that the true difference of proportions, I have to read difference of proportions, and I did girls minus boys. Language students Why did I write? Oh, what if you did? Yeah, good question. So if you did boys minus girls, completely fine. You're going to have an absolutely correct answer. The only thing that'll be different, your interval will be switched. It will be negative 0.109 to positive 0.079. They're both right. Okay? It's just talking about which one you're subtracting from which one. Okay? And does it make sense that you have a bigger negative interval if you're doing boys minus girls? Boys were a little bit smaller in proportion than the girls. Okay. All right. Let's see. Who dress up for Spirit Days? Is negative 0.079. So you don't have to include this in your interpretation. What number is in this interval that might be important? Is 0 in here? Yeah, what would it mean if the true difference in proportions was 0? That they're the same. Yeah, the truth is the boys and girls dress up the same amount. Okay, that's just one option for what is in here, but it's good to be aware of when your interval includes 0, what that means. Okay? Questions so far? Are we hanging in there, guys? Okay. We're going to talk about pooling our data now. So we're going to go back this way a little bit. This page. Special situation for 2 sample hypotheses for proportions, all pooling. Okay. The only time you have to do pooling is if you are told that the 2 proportions you're looking at are equal to each other. Okay? They also won't tell you what those proportions are, just the fact that they are equal to each other. So this is the only time if your null is that your 2 proportions are equal. So let's think about what this means as far as writing our null hypothesis. If P1 equals P2. Is that the same as P1 minus P2 equals 0? Okay, and does that make sense? If they're the same, the difference between them would equal 0. Okay, you could certainly also do it as P2 minus P1 equals 0. The only part of this that becomes interesting then is when you're finding your p hat. You actually just combine the two p hats into one new p hat. The reason being, if the proportions are actually equal, why wouldn't you just look at them together as one p hat? Okay. We're going to do an example that deals with pooling to make sure we're all on the same page, okay? But this is just a very special case only when P1 equals P2. Okay? All right, so let's look at it in an actual problem. So back to the page we were just on. I don't think we're going to do this one. So cross that out so that you've got a little more room to work with here. Okay, so let's look at this two proportion significance test here. All right, so we're using our data from part B. Is there significant evidence at an alpha level of 0.05, that's our significance level, that the same proportion of boys and girls dress for Spirit Day at Langling High School? Okay? The same proportion, right? What does that mean about P of girls and P of boys? Equal. Yes, so that's what we are talking about. These two are the same. And do we know the specific values for those? No. Remember up here when we did this problem, part B? We didn't know these two. We didn't know the population proportion for girls and for boys who dress up. Okay. We're not going to recheck conditions or redefine our parameters, anything like that, because we just did it in part B and we're using the same values. We are going to write a null and an alternative. So since these two proportions are supposed to be equal, my null is going to be that P sub G minus P sub B equals 0. What do you think your alternative is going to be? Not equal 0. Yes, good. We didn't talk at all about one being greater than the other, anything like that. We just want to know, are they the same or are they not the same? Okay, so that's why we're using the not equal to there. Okay. We need a p hat value here. So we are going to have to do the p hat pool. So we make one fraction out of our two p hats here. So from part B, how many girls dressed up and how many boys dressed up? Wasn't it like 127 for the girls and 118 for the boys? And then what, 210 and 200? So you are making this new fraction that is 245 out of 410. Like 0.597. Okay? Because it's pooled, we're combining those two p hats together to make this new pooled p hat. Okay. Let's look at our z-score for this. We'll write the formula. That might be about all we get. All right, so p hat of girls minus p hat of boys. We still know that. And then minus P sub G minus P sub B. Okay, look at that numerator for a second. Denominator. P sub G times 1 minus P sub G over N sub G plus P sub B times 1 minus P sub B over N sub B. Okay, a lot going on in that formula, right? A whole lot of subscripts happening. Okay, do we know P hat of G and P hat of B? Yes, we were told those values in part B of this problem, right? Okay, we'll continue after lunch. The exciting conclusion. Guys, all we need to get through for today is finish the pooling problem, and then you'll have the rest of class to, get your life back together. Yeah, okay, so we're almost done, okay? All right, so again, let's talk about the formula. We know P hat G, we know P hat B, right? Yeah, okay, do we remember before lunch what was happening? Yeah, okay. What about this whole P sub G minus P sub B? We don't actually know those values, right? Well, yeah, that's going to be 0, right? Okay, that's good. Now, again, I don't know P sub G and 1 minus P sub G. I don't know P sub B and 1 minus P sub B. But I did this P hat pool business over here. Do you think I should maybe use that somewhere in my formula? Yes. Yeah. No, that was just a side note, just for fun. No, we're going to use that. That goes in here. Okay? But the sample size for girls, sample size for boys, we know that, right? Okay, so let me show you. We'll plug all the numbers in so you can see what it looks like. Hopefully I have enough room right here. So we've got our 0.605 minus 0.59. And then we said that whole thing would just be 0, right? All right, then over the square root of, it's going to be 0.597. That's our P hat pool. 1 minus that would be 0.403 over 210. Right, that was, and then same thing, 0.597 times 0.403. It almost fits over 200. Let's see what we get for a Z here. I want you to try to key all of that in, okay? I know what the answer is. I want to make sure you can get the answer. Use the fraction key. Use all of the little things to help you. Oh, welcome back, Michelle. I know it's going to take you a little while to see it. Everybody knows the fraction shortcut key?
Up step on.
Alpha equals, yeah.
Yeah.
Same thing. Yep. What do you think?
Really nice.
Yeah, 0.301. Yeah.
It's 0.3095.
Yeah, 0.310. That makes more sense. Are we getting 0.31? Yes.
Oh, I did 0.405. I did 0.405.
So now
I just got a bigger number.
key in, 0.605 minus 0.59.
I don't know how to play numbers.
Yeah,
You see this? You don't really need the minuses.
I just
You have it written down, okay.
right here, 0.5 and 9.
Okay, now, and now do square root.
I'm saying back. Really fast.
Light changing day here.
Like by the end of the day.
I should have done an A minus. I missed something. I mean, I got the last question wrong in all the true false. I didn't. So like I said, getting that one wrong, but the other two I knew they were
Okay.
Like I don't know what else to call Oh, you did 4, 6, 3, and
Oh,
I love it.
All right. So we get a z value of 0.31. We have to think about what that means now. So pretend this scribbly thing isn't here. Let's make a picture. What's going to go in the middle of my picture? All right, guys, what goes in the middle? 0, yes. Nice.
Oh,
Z is 0.31, so it's over here. Now, was this a one-tail test or a two-tail?
two-tails.
2, so I'm also going to do negative 0.31, right? Shade out here. Shade over here. We're okay with that. How do I find the area of the shaded stuff? Norm CDF, okay. So I'll do negative infinity, and then you pick one of them. I'm going to do to negative 0.31, 0, and then 1, because we are standardized, right? We took the time to find the z-score, so we can use that. And I get like 0.382, right? Yeah, we got to do it times 2, because that only gives me one side. Well, we standardized it already with the z-score, so you're okay with that.
That's the right standard deviation. Oh.
Because it's 0 and 1, right? That's the benefit of doing it with the z, is that you don't have to label it again. So my p-value then is going to be 2 times this 0.382. There was more to it. It comes out to like about 0.763. I like doubled the whole value instead of just what I wrote down. Fine. It's not at all close to our alpha level, right? Okay. Yeah, and even, so let's say you do the test, you completely mess it up somewhere, and you get a completely different p-value, but you interpret your p-value correctly. You lose the point for the mechanics, but you could get the point for the interpretation. It's like a character error. But you have to interpret it correctly based on whatever your p-value is. I'm almost done with everybody's first one.
Okay, so like the one where it asked like the marginal error one, they asked you how many houses, and then I was like, is there like a varying answer that you can get or to an exact number? It's like something like
No, it's different depending on how many decimals you used on the critical
Okay.
value and stuff like that. Yeah.
just because like I wanted like to figure out if there's like any like Christian gap.
Yeah, there's several answers.
Okay.
All right, guys, we just need to write our conclusion. Our p-value is 0.764. Is that bigger than alpha? Yeah, quite a bit bigger, right? Okay, so since our p-value of 0.764 is greater than alpha of 0.05, do we reject or fail to reject? Okay. We fail to reject the null. There is not enough evidence to suggest that the proportions of boys and girls Langley dress up for Spirit Days. Almost there, guys. Says Spirit, I promise. Are not equal. Yeah. Whew. Remember, our alternative hypothesis was that they were not equal. That's what you're using in here. There's not enough evidence to suggest your alternative hypothesis. Okay, just with the context of all of it. How we doing? Hands are tired. Yeah. How are we going to make them equal for the null? If we get, let's see if I can get all the way back to the problem. So when it says the same proportion, that would mean the proportions are the same or the proportions are equal. So that's where that comes from. So we want to know, is there evidence that they're not the same? That's what this is, yeah? No. Your null is never a not equal to, a less than, or a greater than. Null is always equal, and then the alternative is always the inequality part of it. Okay? All right. Okay. Let's stop there.